Right. Now,
Yeah, that's good.
what we have done in differentiation is you have differentiated from the displacement as a function to the velocity, and velocity, you have differentiated velocity to acceleration, right? So this time with integration, we are actually going backwards rather than going forward. So by the end of the lesson, you should be able to determine the equation of velocity, displacement of an object moving in rectilinear motion, given acceleration using integration technique, all right? You need to know your integration technique. You're moving backwards. Again, solving initial problems. Once you know the initial problem, you should be able to solve it. Let's look at graphs as well. You need to be able to look at graph and then work out the area under the graph, all right? And then you need to know the absolute area under graph is a distance, not a displacement. We'll think about the displacement and distance. Now, this is just a quick summary. When I go from displacement, the function of displacement, if I take a derivative, I get the velocity function, all right? Which is the rate of change of the distance. Then the rate of change of velocity is acceleration. I take the differentiate velocity, I get acceleration. Going backwards, integration and integration. Integrating acceleration, we get velocity. Integrating velocity, we get acceleration. Alright? So, it's basically we are moving backwards now. But the thing is, we need to be able to look at graphs. Think about things like the displacement. Now, the first one is pretty straightforward. It's an initial function problem. Initial value problem. So now you've got a particle traveling in a straight line. So straight line, you know it goes forward and backwards, and you got all upward and downwards, or backwards and forwards, or backwards, forwards, upwards, downwards, left and right. It's just a straight line. Make sure that you know what is defined as positive. This one, there's no definition, but you need to think about how you're going to work from here and to the velocity and the displacement. All right. Now, in terms of units, it can be meter per second squared or meter second to the power of 2. All right, that's fine. So I interchange between those two. That's for acceleration. For velocity, generally is meters per second or meters second minus 1. And of course, XD would be meters. All right? Now, think about this as a integration problem. You're going to integrate the acceleration to velocity and then to distance. But then, what it gives you is not t equals to 0. You have t equals to 3 seconds. After 1 second. After 1 second, the velocity is 5 meters per second, and the displacement is 4 meters. So you know that this is v1, which is 5 meters per second, or x1, which is displacement, which is 4 meters. Now, you need to actually go back and integrate the acceleration to get the velocity first. All right? So it's quite important to be able to write down vt, what vt is. Now, because we are not looking at definite integral, you need to know how to determine c. Determine c, you use v1. v1 equals to 5 meters per second. So substituting, c equals to 1. Now, I always like to write out the equation. All right? Please, in the exam, always write out the equation. Do not just leave it as c. Always write out the equation. Make sure that's plus. The whole equation is there. All right? Then you can substitute to find the velocity after 3 seconds. From here, you'll be able to integrate and then find the displacement, xt. All right? So, let's try working on the displacement.
meters integration. What do you think? The displacement. Fast displacement.
All right, so you can work out V3 velocity at
Not distance.
3 seconds is 49 meters per second. Now,
Displacement's the net change.
remember, write the units. And then the next bit, integrate
Yeah.
VT. So integrating VT, C, I put down this equation plus C. Now, the thing is, you got to realize that this C is different from that C. All right? Two different C. If you like, you can use this as C1 and this as C2, or use a different constant. Do not get it mixed up. All right? Those two C's are different. I just wrote it down as C. It's just my habit, that's all. Could be C1 and C2. So again, initially, x1 equals to 4. You should be able to find out that C is actually 2. All right? From there, I always say write down the equation properly, and then you can substitute. Substitute T as 3 in, and it should be 50 meters. All right?
Sir,
Yeah?
can you just do like 4 plus the integral of velocity from 1 to 3?
Don't know, we can try. I haven't tried that.
Yeah.
I haven't tried that. You can try.
Yeah, okay.
I haven't tried that.
What do you mean?
Because you get the change
Yes,
from 1
you're going
to
to change
3.
from one. You
Yeah.
potentially could. You can
Yeah.
try that, but don't know.
I need to try. I've already done it.
Yeah,
Just checking if it works.
good question. But normally in this sort of situation, normally you have to find out C because the next bit you can't. You have to use a C to integrate to get the distance, the displacement.
No, displacement. That's how I got displacement. It's like,
Oh, sorry, you did not the velocity. The velocity you're gonna see. Yeah, you can.
Yeah.
You can do that. All right. All right. Next, example 2. Here, basically, it's the same idea as example 1, but this time I'm using a cost function. That's all. So the acceleration is a cost function. You must be able to integrate the cost function. All right. Now, here you need to think about right and left as positive. Right is positive, left is negative. It's very clear in the question there. Right is positive, left is negative. All right. Right is considered to be the positive direction. So, from there, again, read the question. Initially, the particle is traveling to the right at a velocity of 10 meters per second from the point that is 5 meters left of the origin. Determine the position of the particle. So, initially, if this is origin, all right, the particle is traveling left. This is 5 meters left. And velocity is 10 meters per second. All right? So what you could do is work out the velocity function, integrating the acceleration function. Now what I've done is I split it into integrating the cos pi t over 8 and then integrating the 2. It makes life a little bit easier because you do know that you need to include pi over 8 in the integration. So in the pi over 8 there, and you need to include 8 over pi, so that equals to 1. All right. So therefore, I actually use the linearity property of integration. I split it into 2. Makes life just much easier for myself. And with that, you should be able to work out Vt is that. Now, with this situation, I am pretty sure this question can be done without calculator. The answer you should be able to get without calculator. you should work out, since V naught is 10, so C is actually 10. Alright? Then you start thinking about the displacement. What is the displacement? So we write out the velocity function properly so that I know I need to integrate the 10 as well. Alright? Always write out the function once you've integrated so that you know which one, what to integrate.
64
Alright.
pi squared times 0.
0.
Yep, so it's going
Where you
into
get this
64 over pi squared.
I think
You're right. So you can see that
Because it's the integral
from here,
because
I need another
Yeah.
pi over 8. So therefore, I have to include another 8 over pi, which means I've got 64 over pi over 2. Plus, it has to be a negative value because sine pi integrating sine is minus cos. Remember, v dx of cos is minus sine. And with that, you should be able to work out x0 is minus 5. Alright? Now, cos 0 is 1. So therefore, d is not actually minus 5. D in this case, I use d instead of c2 or c. So d in this case is 64 over pi squared minus 5. The constant now is not just minus 5. Alright? You cannot always, in this sort of situation, you cannot always assume that this is 0 because cos 0 is 1. So therefore, you need to work out what the constant is. And we write everything out properly as a function. I ran out of space, so I went over 2 lines. Alright? And then you should be able to determine x when t is equal to 4. I'm pretty sure, oh no, actually, you need to work this out with a calculator at the last bit, 25.48 meters. Now, answer the question and say that the particle is 25.48 meters right of the origin at t equals 4, okay? Right, always say whether it's right or left. So if it is positive, it's right in this case. Because it's defined for you, positive is in the right. Alright, these are all pretty much using your idea of initial value problem. Next thing we're going to look at is actually look at the distance traveled and or the displacement. Alright? Now here, think about net change or the total change. We're going to use delta again. Delta x or delta y. Go back to your total change lesson about three lessons ago. So the net change or total change in displacement or position and velocity can be thought of as a sine area under the velocity and acceleration curves respectively. Alright? So displacement. Remember I said displacement has a sign. So displacement could be positive, could be negative. Velocity could be positive, could be negative. Therefore, the idea of signed area is very important because you've got a positively signed area and negatively signed area. Alright? So the displacement is actually the positive plus the negative, and you may come up with the negative value because the displacement is on the other side. So what you need to think about the change in displacement is the definite integral of velocity function to account for positive and negative displacement. So it is a sum of the signed area. Whereas the total distance traveled. Total distance traveled is distance has no sign. So therefore it is a physical area. So the difference is the physical area and the sign area. The change in displacement will be the sign area. whereas the total distance will be the physical area. That's all. So we call back your physical area and your sine area. And then change in the velocity is the definite integral of acceleration function. Alright? Now, if you ask to find the speed without the average speed without any sign is actually the total distance divided by time. Alright, that's average speed, not the velocity. The change in the velocity, you've got to use the integration. Everybody happy with that? Yeah? If you are, let's do an example. Example 3, I've highlighted information. The velocity of a vehicle increases from rest to 0 to 80 kilometers per hour in 30 seconds under constant acceleration. Now, the word constant is important. All right? Here, acceleration is not, it is a function, but it's a constant number. So A, T is a constant number. It doesn't matter, whatever it is. Let's say AT is K. All right? So VT will then be KT plus C, correct? Yeah? Because you need to integrate that. Think about this. It's a constant. If you're integrating a constant, you got a T or X. Yeah? So now, let's think about here. You're given this in 80 kilometers per hour. And you're talking about 30 seconds.
Kilometers an hour.
And you want to see the net change in position in meters. So you need to actually change your speed. Definitely change your speed to meters per second. Alright? Assume that all of you know how to convert from kilometers per hour to meters per second. Yeah? Multiply kilometers by 1,000 to change it to meters. The hour divided by 3600. 3600 seconds. Alright? So therefore, I'm leaving it as fraction because you can work this one out as a fraction. Now, so I can work out A, acceleration is basically 200 over 9, which is your velocity, divided by the time, which is 30 seconds. Alright? Remember, acceleration is velocity divided by time. Meters per second square. Alright, so it's 20 over 27. Yeah? Fair enough? Yeah? Alright. So next, because it's a constant, I have to integrate this constant to get the velocity function. So the velocity function is therefore 20t over 27 plus c. Now, when t equals to 0, what is c? At rest, from rest. Rest means 0. 0 to 80 kilometers per hour. Alright? So t equals to 0 is that? This is t equals to 30 seconds. So therefore, c equals to 0. The velocity function is 20t over 27. Now the thing is, all this integration and stuff like that, you should know. It's just, in this sort of situation, it's just a matter of interpreting the question. How you interpret the question, what is at rest, and when the velocity, and things like time, and things like whether it's constant acceleration. So it's how you interpret the question that's important. So once you've done that, you should be able to think about the change in position. You want from 0 to 20. Alright, this is change in position, is net change in displacement. Alright, change in position is a total change. Total change in displacement. So you can just find the integral. If it is negative, which means it's in the negative side. If it is positive, then it is on the positive side of the origin, wherever the origin is. So therefore, if you work this out, the answer should be 333 and 1/3 meters. So that is the net change in position. All right. So here, you know that it's constant acceleration. So it keeps going faster and faster and faster. And yeah, it did not really say, I would say that that is actually in the positive direction. So therefore, this is correct. So there's change in the position. And really the change in the position is really think about the sign area. Don't worry about whether there is, when you look at the net change, you don't even have to worry about whether there is a root, because it's accounted for. All right? The root is important when you want the total distance. All right?
So do you not need to account for, can you not say that's on xt?
Or you can say xt, but it's delta x anyway because it's change in position. You're doing the definite in integral. So this is actually delta x because you're doing the net change in x. All right? All right, let's go to example 4. Example 4, an object is propelled vertically upwards 2 meters above the ground. Now,
projectile motion.
here, I highlighted 2 meters above the ground because later, when you think about the position of the object after 3 seconds, you need to include the 2 meters. If you don't include the 2 meters, the answer is going to be 2 meters less. All right? So think about that. If this is the ground, this is the ground, the object is propelled from here. That's 2 meters above the ground. And that is the velocity, 25 meters per second. Given that the object falls at a constant acceleration of minus 9.8 meters per second squared. So if we are propelling the object up, all right, the object is going up, gravity is pulling it down, right? So the acceleration due to gravity is minus 9.8 meters per second. So this time, you know that it is decelerating because the velocity is going up, whereas the acceleration is pulling it down. All right? You're propelling it up. So instead of increasing, it is actually decreasing. Right? So the speed is, the velocity is decreasing. It's not accelerating, it's decelerating, it's slowing down. It's going up, velocity up, but gravity is pulling it down. All right? And acceleration due to gravity is minus 9.8 meters per second squared. So find the velocity of the object after 2 seconds. Now, again, you know that acceleration due to gravity is constant. It's pulling it down. So therefore, A is minus 9.8 meters per second. So after 2 seconds, you need to think about from 0 to 2. All right? And velocity is a vector quantity. So therefore, you can use a definite integral. 0 to 2. It's not a physical area, it's a sign area. Once you've done that, you know that delta V is minus 0.6. Now, is that good enough? No. Because the initial velocity is 25 meters per second. And this is the change. This is the change. Delta V is the change. The change in velocity. Therefore, you need to include that initial 25 take away 19.6. You can see that it's slowing down. It's not, after 2 seconds, the velocity is not minus 19.6. The velocity is this, take away that. This is the change. Think about the change, and then use the initial value, take away the change. All right? Take away the change. The
Because of the
velocity has
mass,
decreased by
can just
19.6
go
meters per second to 5.4 meters per second.
My
Alright,
ego hurts
so
way
think
more
about
than your
what the negative means. That doesn't mean that it's a negative velocity.
No.
That is a change in velocity. That's a change from 0 to 2. It's a delta V.
It
That's
says
why I wrote
find
down
the
there delta V.
velocity.
So you don't need to find the change, right?
Sorry?
It says find the velocity,
says
not find the change in velocity.
Yeah, but you need to do that first before you can find the velocity. If not,
Can you
how are you
just-
going to find the velocity?
You just differentiate it, and then
I integrate.
you know it's 25 when it's 0. So it's negative 9.8 t plus 25.
Yeah, you can do that as well.
You can do that as well. You can do that as well.
That's
I'm
what I-
using the net change to show you. Yeah, you can do that as
the
well.
normal way.
All right.
You integrate it and
You just
solve
do
it.
like you just find v basically. You find the equation of v.
So you have A and then you just integrate A.
All right.
Integrate a to get
Next.
negative 9.8 t plus.
So
c.
now we know that the velocity
Yeah.
function is
And then T is 2.
minus 9.8 t plus c, and when t is 0, c equals to 25.
Because you got c
Therefore,
equals
yeah,
25.
vt equals to minus 9.8 t
C
plus
is
25.
25.
You can do that as well. That's
Yeah,
fine.
that's what I-
It's the same thing because it's substituting 2 in. Minus 9.8 times 2 is minus 19.6. You can do that. All right. So therefore, when we want the object first come to a rest,
What are you getting with it?
is when velocity equals to 0. Now remember, when the object is resting, the velocity is 0. So therefore, t equals to 2.55 seconds. And then
I don't know, mate.
determine the position of the object after 30 seconds.
I love
Which
bumming
means you need to
Just
start
respect
thinking
us.
about
Yeah.
the delta x. Alright? The change in position, minus 9.8 plus 25. Integration of the vt, you'll get the xt. Alright? But I'm looking at the change. So you now know it's from 2 meters and going above, the change in height. Alright? So you can work out the change is 30.9, but you need to include the 2 meters above. Alright? Of course, if you want, you can find the c. That's alright. Find c and then work out what xt is for 3. That's fine. But if you do it this way, you need to add the 2 meters. And you've got 32.9 meters, and the object is 30.9 meters above the original position,
Must be, yeah.
which is 32.9 meters above ground.
Whoa. Yay.
Last question for test. Last question for test.
All right,
One more question.
one more question. Now, the next example is really important for you to be able to interpret the graph,
Classic.
which is what I find very interesting with the last test. Some of you interpreting the graph.
Yeah, I didn't do that. Yeah.
Yeah, I didn't get
So the
that.
Not as well.
The cusp
All right,
have no grade.
here,
Yeah,
if you
alright.
look at this
You get
graph,
that?
let's have a look at this graph.
Oh, okay.
Now,
But see, because like here, right? The cusps.
here,
There's no
the
grade.
graph here is
Yeah, you
VT,
can't include
not
that.
XT. All
I
right?
did that.
You included it.
When you
No, I didn't.
are given a graph
okay,
like
you wrote it
this,
at 6 a.m.
Oh, I
make
see.
sure that you know what this is.
I think this one.
You know that the x-axis is
I missed-
always
in
time.
one of them I did.
You need to know whether
One of
this
them I did
is
that.
velocity or acceleration
Last one.
But
or
yeah, true,
displacement.
yeah.
All right? So now you know
No,
VT
no.
is
It
this.
was for this
The
one.
y-axis is given as
Okay,
VT
true.
and stated here as well.
Yeah.
All right?
That one.
Make sure that if it's
Yeah,
not
'cause
stated
grade
here,
is
make sure
zero.
that you read and know what the y-axis is.
Yeah, no, but the other part on it.
Now,
Like, Brett
let's
asked
think
you
about question like this. State the time when the particle at rest is when Vt equals to
0.
0. So you're looking at the roots or
0,
the
8,
x-intercept. So I've
20,
highlighted the 3 points,
7.
which give you t equals to 0, 8, and 25 seconds.
So is 0 included? Or
0 is included because you're starting 0 from rest.
Yeah.
Yeah, you have to include this one.
Alright.
So,
Test 0.
what is the acceleration of the particle when t equals to 5?
0.
0, because the velocity is constant. There's no acceleration, right?
Yeah.
So, it's 0 meters per second.
Acceleration.
during which interval is the particle experiencing a constant positive acceleration. Now this is a bit, you got to be very careful. You know these are the 2 points.
0 to 4, but not including 0.
Yeah, it doesn't include 0 or 4.
No cusp.
It doesn't include 20 and 25 as well, alright?
Wait, why doesn't it include 25 and 0?
Sorry?
Why doesn't it include 25 and 0? Because
At the start it's at rest. So when it starts moving, so it's just a little bit over, then it start go all the way up, and then when you get reach 4, it stop.
Okay.
And constant velocity.
Yeah,
Alright, it's not
I lost
accelerating at
those
that
marks.
point.
lost those marks. No.
Alright? So you got to think about it that way. And then the next one, determine the total distance traveled by the particle over 25 seconds. Total distance,
Physical area.
physical area.
Oh, counting squares.
So physical area,
Probably bothered.
you need to work out the physical area, which is the total distance. Alright, 120 meters. Now, you know that
Okay.
here under this point is 50 already,
I won't capture
and
it.
that is 70. Alright,
Yeah, David, I'll
we'll
finish
use
it.
the idea to answer the other 2 questions. The other 2 questions, E, determine the displacement or change. So displacement is the sign area, which is this positive plus negative, correct? Positive plus negative. So therefore, it's 50 minus 70, which is 20 meters.
Distance is
Alright.
the physical area.
Now, and the particle
So it's
has
this
therefore
one.
moved backwards
Yeah, this one.
20 meters from the starting position.
But remember, that will be negative, so you've got to make.
Last one.
Yeah.
You need to find the times when the particle returns to the starting position.
I said area equals 0.
Alright? So, when it returns to the starting position, the displacement is 0. This area plus this area has to be 0, correct?
Yeah.
Yeah?
I guess it's
So you need to
roughly
find
18,
what the k value is.
6.
No, it's 18.5.
Is it
Actually,
You know what? You need to find what the k value is. You know this is a trapezium. You know this is a trapezium as well.
Ooh, that was
Alright?
cold.
So
just let me.
just work out
Hey.
the area. This area has to be the same as that area, which
At the
means
top,
there has to be
so
minus
positive area is
50.
50. Minus that little triangle there, because of course that's
Alright.
cancel it out, right?
So what I've done here is
This positive area here, minus the small triangle, because it's way smaller.
I have
We guarantee that.
work out what
You're
the
not gonna
area
get
is
zero.
with k.
And then plus
K
the
minus
value of
8
k.
and k minus 9 times 5, which is the height, and half of it is 50. So I work out k to be 18.5, or
Or 0.
the particle will return. Cannot be 0 because it's returning to its original position.
true.
Cannot be 0,
Yeah.
alright?
Yeah.
So it's 18.5 seconds.
It must be 0.
Alright. That's all I have for you today.
Wait, why can't it be 0, sir?
Because you are returning to the position. You are returning now back to the position, so cannot be
You
0.
can't return if you're there in the first place.
Yeah, you can return when you're there in the first place.
Minus a little